How did our gentle blue planet, a haven of life and tranquility, emerge from such violent cosmic chaos? What series of events transformed a ball of molten rock into the world we know and love today? To answer that profound question, we must embark on a journey back 4.5 billion years, traversing the vast expanse of time. We must travel to a time when the solar system was a violent construction site, a chaotic arena of cosmic collisions and planetary formation. A young sun, still in its infancy, blazed fiercely at the center, radiating immense energy and light. It was surrounded by a swirling disk of gas and dust, the solar nebula, the very cradle of our planetary system. Within this swirling nebula, tiny grains of dust, microscopic in size, collided and clumped together. These clumps grew larger and larger, accumulating more mass, growing from mere dust to substantial boulders. Eventually they evolved into planetesimals, the very first infant worlds, the seeds of future planets. Earth began its existence as one of these planetesimals, a small rocky body in the early solar system. But it was caught in a deadly cosmic dance, a chaotic ballet of collisions with other planetesimals and space debris. Each impact was a cataclysmic event, releasing enough energy to melt the growing planet entirely. This constant bombardment transformed Earth into a molten sphere, a glowing orb of liquid rock. In this fiery environment, no solid crust could possibly survive for long. Every attempt at forming a stable surface was shattered by the relentless bombardment of asteroids and other space rocks. This period of intense bombardment and volcanic activity is known as the Hadean Eon. A truly hellish molten world, a landscape of fire and fury. There was no air to breathe, no water to drink, just a vast glowing ocean of molten rock stretching across the planet's surface. During this time, the late heavy bombardment pummeled Earth with an unprecedented intensity. The constant impacts erased craters almost as quickly as they formed, leaving no lasting scars on the molten surface. Yet, even within this seemingly endless chaos and destruction, the essential ingredients for our planet's future were being delivered by these very impacts. The extreme violence that defined Earth's earliest days, its very birth pangs, also inadvertently seeded it with the fundamental building blocks of life itself, carried on the backs of asteroids and comets. Our world was undeniably forged in fire in the crucible of extreme heat and pressure. It was shaped by destruction on a colossal scale, yet simultaneously primed for an incredible transformation, a journey towards habitability. And so, from this seemingly uninhabitable inferno, the remarkable story of our living planet, teeming with life, would eventually begin to unfold. The very seeds of oceans, the foundations of continents, and the potential for life itself were all sown in this planetary crucible, this period of intense heat and bombardment. The cosmic chaos was not the end of the story, but rather the absolutely necessary beginning, the foundation upon which everything else would be built. Out of the fire and fury of its tumultuous birth, Earth's incredible journey had only just begun, a journey that would ultimately lead to the world we know today. 50 million years after Earth's initial formation, a period of intense bombardment and planetary construction was still underway in our young solar system. A planetary sibling, a Mars-sized world scientists have named Theia, was inexorably on a collision course, hurtling through space towards our nascent world. The impact that followed was nothing short of catastrophic, a cosmic event of unimaginable scale. The force of the collision vaporized Theia almost instantly, simultaneously blasting vast quantities of Earth's mantle out into the void of space. This ejected material, a swirling cloud of molten rock and debris, began to coalesce, forming a ring encircling the Earth. This ring glowed with intense heat, a fiery halo of incandescent material surrounding our planet. But amidst the chaos, gravity, the architect of the cosmos, began to work its silent, powerful magic. Slowly but surely, gravity gathered the orbiting debris, pulling it together into a single, unified celestial body. The Moon. In those early days, the Moon loomed incredibly large in Earth's sky, a massive presence dominating the heavens. Its proximity meant its gravity exerted a far stronger pull on Earth than it does today. This immense gravitational influence acted as a stabilizing anchor, gradually settling Earth's axial tilt. This stabilization was crucial, ultimately giving us the predictable and reliable seasons we experience today. Furthermore, the Moon's relentless gravitational pull acted as a brake, gradually slowing Earth's once rapid rotation. Over eons, this slowing stretched our days from a mere 6 hours to the familiar 24 hours we know now. Without the moon's steadying influence, Earth's axis would likely wobble chaotically over time, leading to dramatic and unpredictable shifts in climate across the globe. In essence, the moon's very creation tamed the primordial chaos, bringing a measure of stability to our volatile young planet. It established fundamental rhythms that would eventually become intertwined with the development of life itself. The moon shaped the tides, not just the familiar tides of water that sculpt our coastlines, but also the less visible, yet equally powerful tides of molten rock deep within the Earth. These internal tides played a crucial role in helping to cool and stabilize the Earth's geological activity over billions of years. And so the moon became our constant companion in the vastness of space, a silent witness to the long and complex transformation of Earth from a molten ball to the vibrant world we know today. Its enduring presence has been absolutely crucial for the long-term stability and the delicate balance of conditions that life would eventually come to require in order to flourish. That great cataclysmic collision gave us far more than just a beautiful nightlight in the sky. It bestowed upon us a fundamental balance, a cosmic equilibrium that has shaped our planet's destiny. Earth and moon, forever bound together, born from an ancient act of cosmic violence, became inseparable partners in the intricate and ongoing dance of life. After the moon-forming impact, Earth was a churning ball of molten rock. Heavier elements like iron and nickel sank to the center, forming Earth's core, while lighter silicates floated upward. This planetary differentiation created a layered world: core, mantle, and crust. The core's movement generated a powerful magnetic field, the magnetosphere. This invisible shield protects us from deadly solar wind, preserving our atmosphere and oceans. Without it, life would be impossible. The auroras are a beautiful reminder of this shield in action. The formation of the core didn't just give Earth structure, it gave us a guardian. The magnetic field is a legacy of our planet's fiery beginnings. It's the reason Earth remains habitable, even as the sun bombards us with radiation. Deep within, the planet's heart still beats, defending the surface. The stage was set for the next transformation. As Earth's interior settled, its surface erupted with volcanoes releasing trapped gases in a process called outgassing. Water vapor, carbon dioxide, nitrogen, and other gases spewed into the sky, forming Earth's first atmosphere. But this was no breathable air, it was a toxic, heavy blanket, thick with greenhouse gases. The sky glowed orange or red, choked with volcanic dust. No oxygen, no ozone layer, and a crushing pressure made the surface utterly inhospitable. The greenhouse effect kept the planet scorching hot despite a fainter young sun. This atmosphere was in constant flux, battered by impacts, and replenished by eruptions. There was no protection from ultraviolet radiation, the surface was deadly. Yet this toxic shroud was the raw material for the air we breathe today. The early atmosphere was a necessary step toward habitability. Volcanic outgassing set the stage for future transformation. The planet was primed for the arrival of water. The next chapter would bring the world's first oceans. For millions of years, Earth was too hot for liquid water. Water vapor from volcanoes stayed in the atmosphere, but as the planet cooled, the first crust formed. Water locked in rocks and delivered by comets and asteroids began to accumulate. Eventually, the atmosphere cooled enough for rain to fall, a deluge that lasted thousands, maybe millions of years. Oceans formed, filling craters and basins left by ancient impacts. These early seas were hot, acidic, and mineral-rich, nothing like today's blue waters. The moon's gravity whipped the oceans into a frenzy, shaping tides and coastlines. But it was water, liquid, life-giving, and transformative. The arrival of oceans turned Earth from a barren rock into a water world. Water became the essential ingredient for life's chemistry. The planet's surface was forever changed. The stage was set for geology and biology to intertwine. The restless Earth was ready for the next act. With oceans in place, Earth's surface was still unstable. Plate tectonics began, driven by heat from the mantle, breaking the crust into drifting plates. Where plates collided, volcanoes erupted and mountains rose. Where they split, new crust formed. Subduction recycled oceanic rock, creating lighter granitic continents. This geological engine kept the planet dynamic, preventing stagnation. Plate tectonics dredged up essential elements, enriching the oceans and land. Diverse environments, trenches, islands, vents, emerged, fueling chemical complexity. Volcanic activity released carbon dioxide, warming the planet, while weathering locked it away, stabilizing climate. This feedback loop, the carbonate-silicate cycle, kept Earth's temperature in check. The restless Earth was a self-regulating system, primed for life. Geological activity created a living, breathing planet. The foundation for biology was laid. With a stable axis magnetic shield atmosphere and oceans, Earth was ready for life's first spark. The surface was hostile, but deep-sea hydrothermal vents offered refuge. Here, mineral-rich water and chemical energy created a perfect laboratory for life's origins. Vents spewed hydrogen sulfide methane and metals fuel for complex chemistry. Porous rocks concentrated these chemicals, enabling the formation of organic molecules. Simple molecules assembled into polymers like RNA and proteins. The first self-replicating molecules emerged, evolving into primitive cells. This was LUCA, the last universal common ancestor. Life began in the dark, powered by Earth's own heat. The spark had caught biology was born. Earth's transformation is remarkable, a testament to the power of planetary evolution. From a fiery ball of molten rock to the vibrant, life-sustaining world we know today, it's a story of constant change and adaptation. But a glance at our celestial neighbors, Venus and Mars, serves as a stark reminder of how fragile habitability truly is. These three planets, born from the same cosmic dust, followed drastically different paths. All three planets began similarly, as hot young worlds forged in the crucible of the early solar system. They were hot and volcanic, with surfaces constantly reshaped by eruptions and lava flows, and quite possibly wet, possessing vast oceans or at least significant amounts of water vapor in their atmospheres. Venus, being closer to the Sun, faced a unique set of challenges. Over time, it gradually lost its water to space, as the Sun's intense radiation broke down water molecules in the upper atmosphere. Simultaneously, carbon dioxide built up in its atmosphere, released from volcanic activity. This led to a catastrophic runaway greenhouse effect, trapping heat and transforming Venus into a scorching inferno. Today, Venus is a furnace, a hellish landscape of extreme heat and pressure. Its thick, toxic atmosphere exerts a crushing pressure on the surface, making it utterly inhospitable. Mars, being smaller and cooler than both Earth and Venus, suffered a different fate. It lost its global magnetic field relatively early in its history. Without this protective shield, the relentless solar wind stripped away its atmosphere, molecule by molecule. As the atmosphere thinned, the planet cooled and its water vanished, either freezing beneath the surface or escaping into space. Mars is now a frozen desert, a cold and barren world. It stands as a relic of lost potential, a testament to the delicate balance required for a planet to remain habitable. Earth, in contrast, threaded the needle, a cosmic balancing act that allowed it to flourish. It was big enough to stay geologically active, maintaining a dynamic core and a cycling of elements. Earth also resided at the right distance from the Sun for liquid water to exist on its surface, a crucial ingredient for life as we know it. Furthermore, it had a stabilizing moon which helped regulate its axial tilt and create predictable tides, and it possessed a protective magnetic field deflecting harmful solar radiation and preserving its atmosphere. This rare combination of factors made Earth continuously habitable for billions of years, allowing life to emerge, evolve, and diversify. Venus and Mars are stark warnings, demonstrating that planetary habitability is easily lost even with a seemingly promising start. Earth's balance is incredibly delicate, meticulously maintained by complex geological processes, intricate atmospheric chemistry, and perhaps just a bit of cosmic luck. Our vibrant living world is likely the exception, not the rule, in the vast expanse of the universe. The contrasting story of our planetary neighbors serves as a powerful reminder of just how precious and unique Earth truly is, a blue marble in the cosmic ocean. The forces that shaped Earth's fiery youth are still at work today. Mantle heat drives earthquakes and volcanoes, reminders of our planet's restless heart. The magnetic field, born from ancient iron, shields us from cosmic danger. Water cycles through rain and rivers, sustaining life, some of it delivered by ancient comets. Our atmosphere, once toxic, was transformed by life, but its origins lie in volcanic outgassing. Understanding Earth's story is vital for our survival. Venus and Mars show how easily balance can be lost. As we alter our own atmosphere, we risk repeating their mistakes. The moon above is a monument to our violent beginnings. The iron in our blood and calcium in our bones were forged in cosmic fire. Knowing our planet's journey connects us to the universe and reminds us to protect this fragile living world. Have you ever looked up at the moon and wondered where it came from? It hangs there, a silent, steady companion in our night sky. But what if I told you its origin is a tale of unimaginable violence, a lost world, a cosmic ghost haunting our planet's past? Scientists believe a Mars-sized planet, Theia, once collided with a young Earth. The evidence is written in the rocks beneath our feet and in the dust of the moon itself. 4.5 billion years ago, our solar system was a chaotic construction site filled with planetesimals, building blocks of planets, jostling for position. Among them, Earth and Theia formed as planetary siblings, sharing a cosmic neighborhood. But there wasn't room for both. Their gravitational destinies were intertwined, leading to a final dramatic encounter. Theia's story is fundamental to understanding why we have seasons, 24-hour days, and tides. The moon, born from this cataclysm, has stabilized Earth's wobble, making complex life possible. So, when we ask where the moon came from, we're really asking, how did Earth become a habitable world? The answer begins with a lost planet named Theia. The moon's presence is a guiding light for life, a clock for civilizations, and an inspiration for dreamers. Its story is our story. Picture the early solar system as a violent mosh pit, not a serene clockwork. The sun had just ignited, and countless rocky bodies swarmed in unstable orbits. Earth was a molten ball, bombarded by debris. No oceans, no continents, just chaos. Gravity ruled, with larger bodies growing by sweeping up smaller ones in a process called accretion. Catastrophic collisions were common, with dozens of Mars-sized objects vying for space. Theia likely formed at a Lagrange point, sharing Earth's orbit for millions of years. But gravitational nudges from other planets eventually pushed Theia out of its safe harbor. Its orbit became unstable, swinging it closer to Earth with each pass. No longer a stable companion, Theia became a rogue world on a collision course. Their paths drew inexorably closer, setting the stage for the most important event in our planet's history. This wasn't just destruction, it was creation. The collision would not destroy a world but create two. The cosmic demolition derby was about to change everything. Theia wasn't an invader, it was Earth's neighbor made of the same stuff. For a time, it existed in a gravitational sweet spot, but the solar system's unruly youth changed that. Jupiter's pull may have nudged Theia from its stable point, warping its orbit. Theia and Earth began a cosmic dance with a series of near misses, each altering their orbits. Gravitational tugs deformed their molten surfaces, creating immense land tides. Each encounter made a final collision more likely, a slow-motion catastrophe. Computer simulations show such orbits are inherently unstable. A collision was inevitable. The final approach was a glancing blow, not a head-on crash. A direct hit would have destroyed both planets, but a sideswipe at the right angle and speed was different. Theia struck at an oblique angle, powerful enough to throw material into orbit, but not to destroy Earth. The physics had to be just right. A cosmic recipe for creating a satellite. The universe amid chaos showed surprising precision. Theia's fate was sealed by gravity and chance. The stage was set for the birth of the moon. How do we know any of this happened? The clues are locked in rocks on Earth and crucially on the moon. Scientists analyze these rocks for isotopic fingerprints, unique chemical signatures. Every planet has a distinct isotopic passport. If the moon formed elsewhere, its signature would differ from Earth's. But Apollo moon rocks revealed something astonishing. The moon's oxygen isotopes are nearly identical to Earth's mantle. This discovery ruled out theories of a captured moon or one formed elsewhere. The identical signature suggests the moon was made from Earth's outer layers, mixed with Theia's material. The giant impact hypothesis elegantly explains this. A collision thoroughly mixed both worlds, creating a homogenized debris cloud. Some elements, like tungsten, show subtle differences, leading to refinements in the theory. Perhaps Theia formed near Earth, or the impact was so violent it created a superheated synestia, mixing everything. The isotopic clues all point to a single violent day that forever linked Earth and Moon. The rocks are our time machines, telling the story of a lost world. The moon is Earth's chemical twin, born from cosmic violence. Imagine that day. Theia, Mars-sized, fills the sky, looming ever closer. Its gravity tears at Earth's molten surface, then impact. Theia strikes with a glancing blow, releasing energy beyond comprehension. The impact vaporizes Theia's crust and mantle, along with much of Earth's. Theia's iron core plunges into Earth, merging with our own and boosting our magnetic field. A vast plume of vaporized rock and dust is blasted into orbit, forming a glowing red-hot ring. Earth becomes a seething ball of magma, brighter than the sun. The debris ring contains the raw material for the moon. Earth's day is now just 5 hours long, spinning rapidly. The collision tilts Earth's axis by 23.5 degrees, giving us seasons. Without this tilt, the planet would be locked in climate extremes. Theia's impact didn't just give us a moon, it gave Earth its climatic rhythm. From destruction came the conditions for life. The moon's birth was a moment of cosmic creation. After the collision, a massive ring of vaporized rock circled the wounded Earth. Gravity took over, clumping droplets into larger blobs. Accretion at work again. The moon coalesced from this debris in a cosmic blink, perhaps within a few centuries. At first it was a molten sphere, much closer and larger in our sky than today. The young Earth and moon were locked in a gravitational embrace, both glowing with heat. The moon orbited rapidly, while Earth spun even faster. This speed difference created powerful tidal interactions. Earth's gravity raised a tidal bulge on the moon and vice versa. The bulge dragged ahead of the moon, pulling it forward and causing it to spiral outward. Meanwhile, the moon's gravity slowed Earth's rotation. This exchange continues today. The moon moves away 3.8 centimeters per year, and our days grow longer. The 5-hour day of early Earth became the 24-hour day we know. The moon's formation set the rhythm of our world. The Theia impact was not just the moon's birth, it was Earth's rebirth. The moon stabilizes Earth's tilt, preventing wild climate swings that could have stifled complex life. Without the moon, Earth's axis could wobble chaotically, causing extreme climate changes. The moon's gravity creates tides, shaping unique coastal ecosystems and, in the past, churning the primordial oceans. Early tides were colossal, mixing chemicals and possibly sparking life. The collision gave Earth its long day and seasons, moderating climate and enabling diverse habitats. The 23.5-degree tilt ensures sunlight is distributed, creating habitable zones. The impact melted Earth, forming a deep magma ocean in distinct layers: core, mantle, crust. Theia's iron core boosted Earth's magnetic field, shielding us from solar radiation. In every sense, we live in a world forged by Theia. Our days, seasons, and even the ground beneath us are products of this ancient event. The moon is a stabilizing force, a legacy of cosmic violence. Without Theia, Earth might be unrecognizable. A good theory must make testable predictions. The giant impact hypothesis has faced decades of scrutiny. Computer simulations act as virtual time machines, smashing digital proto-Earths and Theias together in countless scenarios. Modern models simulate melting rock, debris disks, and moon formation. They show a glancing blow from a Mars-sized body best explains our Earth-Moon system. These models predict the moon's size, orbit, and composition, mostly mantle material with a tiny iron core. But simulations need real data. Enter the Apollo moon rocks. These samples confirmed the moon was once molten and share Earth's isotopic signature. The moon is depleted in volatile elements, fitting the impact theory. Some puzzles remain, like why Earth and moon are so isotopically similar. New ideas, like the synestia model, suggest a high-energy impact mixed both bodies perfectly. Alternate theories exist, but none match the evidence as well. For now, the giant impact hypothesis stands as our best explanation. The moon's story is written in both models and moon rocks. The story of Theia isn't just ancient history, it's unfolding around us every day. Every tide, every 24-hour day, every season is a legacy of that ancient collision. The moon's stabilizing presence may be why Earth is habitable. When we search for life on exoplanets, we now ask, do they have large moons? A moon can anchor a planet's tilt, creating a stable environment for life. The violent birth of our moon may be why Earth is a tranquil blue marble, not a chaotic wasteland. Such a collision is unlikely to happen again. The solar system is now a calmer place. Theia was a product of a unique, chaotic era that will not return. Next time you look at the moon, remember its violent, spectacular birth. It's not just a rock, it's a piece of Earth, a monument to Theia's sacrifice. The moon is a constant reminder that beauty and stability can emerge from cosmic chaos. The ghost of Theia is with us, still a silent partner in the story of life on Earth. June 26, 2025. A seemingly unremarkable date, etched onto calendars and digital displays alike. A Thursday. The kind of Thursday that blends into the background of life, easily forgotten amidst the hustle and bustle. The world awoke to routine, the comforting rhythm of daily life. Alarms blared, coffee brewed, and the machinery of civilization cranked into gear. Commuters in London, packed like sardines into the underground, their faces illuminated by the glow of their phones. Markets in Tokyo, a vibrant tapestry of sights, sounds, and smells, where the day's freshest catches were bartered and sold. Children playing in Cairo, their laughter echoing through the ancient streets, oblivious to the world's worries. The sky was a comforting blue, unchanged and ignored, a backdrop to the human drama unfolding below, a silent witness to our daily lives. Nature moved in its ancient cycles, the ebb and flow of tides, the changing of seasons, the timeless dance of life and death. Jaguars in the Amazon, prowling through the dense undergrowth, their eyes gleaming in the dappled sunlight. Polar bears in the Arctic, navigating the icy wilderness, their survival a testament to resilience and adaptation. Blue whales in the Pacific, their colossal forms gliding through the ocean depths, singing their ancient songs. Life stories unfolded, each creature playing its part, in the grand symphony of existence, each note essential to the overall harmony. Unaware of the cosmic drama about to unfold, a drama that would shatter the illusion of normalcy and rewrite the future of the planet. Above, a 6-mile-wide asteroid, XF-11, hurtled closer, a silent messenger from the depths of space, invisible to the naked eye, a cosmic phantom hurtling towards its destiny and ours. Astronomers had tracked it for months, warning the world, their voices often lost in the noise of everyday life. But for most it was just another news story, a fleeting headline, quickly forgotten in the face of more immediate concerns. The sun shone, birds sang, a symphony of life played on, oblivious to the impending doom, and humanity carried on, oblivious to the approaching cataclysm, lost in the minutiae of their lives, unaware of the cosmic sword hanging overhead. Science had calculated the impact, the numbers crunched, the probabilities assessed, the consequences laid bare. But how do you prepare for the unimaginable? How do you brace yourself for the end of the world as you know it? The universe, indifferent to our routines, was about to rewrite the script. A new chapter was about to begin, one filled with uncertainty and peril. The asteroid's journey, a relic from the solar system's birth, a cosmic wanderer adrift for billions of years, was ending here. Its long voyage through the void was about to culminate in a devastating collision. On this morning it was closer than the moon, a chilling reminder of the fragility of our existence, a silent harbinger of change, a cosmic omen, signaling the dawn of a new and terrifying era. The world's vulnerability was too vast to grasp on an ordinary Thursday. The scale of the impending disaster dwarfed our comprehension. No one looked up. Their gazes were fixed on screens, their minds preoccupied with trivialities. The sky, so familiar, was about to become the gateway for destruction. The heavens, once a source of wonder and inspiration, were now a portal of doom. The end of an era was moments away. The clock was ticking, counting down to the cataclysm that would change everything. The first sign wasn't subtle. It wasn't a whisper of warning, but a cosmic scream. A blinding light erupted, followed by a new sun blazing into existence over the Pacific sky. It was an alien sunrise, heralding not a new day, but the end of one. For a moment the world was bleached white, every color washed away in the sheer intensity of the light. It was as if reality itself had been overexposed. And then, the opposite. Shadows stark and absolute, carved by the unnatural brilliance. The world was rendered in extremes, light and darkness battling for dominance. Cameras failed, their sensors overloaded, their lenses blinded, eyes burned, unable to process the impossible spectacle. And then came the impact, the inevitable consequence of this celestial intrusion. The asteroid, a messenger of cosmic indifference, struck at 40,000 miles per hour, a speed that defied comprehension, unleashing energy beyond comprehension, a force that dwarfed even the most devastating nuclear explosions. It was a raw, untamed power, unleashed upon an unsuspecting world. The ocean flash-boiled, vaporizing instantly in a cataclysmic surge of steam and fury. A crater miles deep gouged into the crust, a permanent scar etched onto the face of the planet. A seismic shockwave rang through the planet, a death knell echoing across continents. The Earth itself shuddering, groaning under the immense strain, its tectonic plates grinding against each other in a symphony of destruction. A 1,000-foot tsunami raced outward, a liquid mountain of destruction, an unstoppable force of nature unleashed, erasing coastlines and cities, swallowing everything in its path, leaving behind only wreckage and despair. Vaporized rock and water blasted into space, a cosmic spray of debris ejected beyond the atmosphere. Soon to rain down as a fiery storm, a second wave of destruction from the heavens. The air became a weapon, a searing blast of superheated gas, shockwaves flattening everything for thousands of miles, reducing cities to rubble and forests to splinters. Forests splintered, buildings vanished, erased from the landscape as if they had never existed, and the sky turned into a ceiling of fire, a burning testament to the planet's agony. The ordinary Thursday was obliterated, its mundane routines and quiet moments swept away in an instant. Physics, not routine, now ruled. The laws of nature, unleashed in their most destructive form, had taken control. The universe had delivered its message, a stark reminder of our place in the cosmos. We live on a cosmic target, vulnerable to forces beyond our control, forever at the mercy of the universe's whims. The fiery rain, a relentless barrage from the heavens, ignited global firestorms with terrifying speed. It was as if the world itself was aflame. Ancient forests, once vibrant ecosystems teeming with life, were turned into raging pyres consumed by the insatiable hunger of the flames. The air crackled with heat and the stench of burning wood filled every corner of the globe. Smoke and dust, a choking, acrid mixture, rose in colossal plumes, blotting out the sun and poisoning the atmosphere. The sky, once a canvas of blue, became a swirling vortex of gray and black. This toxic shroud spread rapidly, forming a dense, impenetrable barrier that blotted out the sun's life-giving rays. The world plunged into an unnatural twilight. Within weeks, perpetual darkness fell, a suffocating blanket that extinguished hope and plunged the planet into an unending night. The age of sunlight, the era of warmth and growth, ended abruptly and irrevocably. The world was plunged into a new ice age. Temperatures plunged with terrifying speed, plummeting to levels unseen in human history. And so, a brutal impact winter began, a relentless season of ice and despair that gripped the entire planet in its icy embrace. Snow fell in the tropics, a surreal and horrifying spectacle, a stark reminder of the planet's altered state. Rivers froze solid, their life-giving waters transformed into impassable barriers of ice. The delicate climate machinery, the intricate system that sustained life on Earth, ground to a halt, its gears frozen and broken. Photosynthesis, the engine of the plant kingdom, ceased as the sun's light was extinguished. Plants died in droves, their withered forms a testament to the planet's suffering. Herbivores starved, their food sources vanished, leaving them weak and vulnerable. Carnivores followed, their survival inextricably linked to the fate of their prey. Ecosystems collapsed in months, their delicate balance shattered beyond repair. Oceans turned toxic, their waters choked with pollutants and devoid of life. Humanity's civilization, once a beacon of progress and innovation, crumbled under the weight of the catastrophe. Power grids failed, plunging cities into darkness and silencing the hum of modern life. Cities froze, their once vibrant streets transformed into desolate, icy landscapes. Billions perished, victims of the cold, the hunger and the chaos that engulfed the world. The world became a silent, frozen tomb, a monument to a lost civilization. Survivors huddled in darkness, clinging to life in the face of unimaginable hardship. Stripped of mastery over their environment, their technological prowess rendered useless. Reduced to mere endurance, their focus narrowed to the basic necessities of survival. The collapse was swift and total, a catastrophic unraveling of the world as they knew it. The planet's symphony of life was silenced, replaced by an eerie and unsettling quiet. The internet, the vast network that connected humanity, the lights, the symbols of progress and innovation, the old world, all gone, vanished beneath a blanket of ice and darkness. We were humbled, brought to our knees by the forces of nature. Shivering in the dark, we faced a future uncertain and bleak, wondering if light would ever return, if the sun would ever break through the oppressive darkness. The cosmos had delivered its lesson, a harsh reminder of our place in the universe. Survival was no longer guaranteed, it was a daily struggle against the elements, against despair, against the encroaching darkness. Yet life endured, stubborn and creative. Deep-sea vents harbored thriving ecosystems, untouched by the sun's absence. On the surface, small burrowing mammals and resilient scavengers found ways to survive. Seeds and spores lay dormant, waiting for a return of light. Mosses and lichens clung to rocks, eking out existence in the faintest glow. Humanity, stripped of technology, became animal again, but with a difference. Survivors gathered in geothermal refuges, mines and bunkers. They hunted, scavenged, and grew fungi in the dark. Evolution accelerated, only the adaptable survived. The specialists vanished, the generalists endured. Humanity's adaptability, our ability to learn and cooperate, became our salvation. In the deepest winter, the spark of ingenuity persisted, a tiny flame in infinite darkness, but enough. Life, against all odds, refused to yield. In the darkness, hope became the rarest resource. Community replaced wealth, trust was the new currency, scattered enclaves wove a new social fabric, survival tied to cooperation, ingenuity flourished, engineers became wizards, patching together warmth and light from scraps. Geothermal energy powered fungal farms and salvage technology. Knowledge was precious. Librarians became guardians of memory. Children born in darkness learned of blue skies and sunlight from stories. Survival became purpose. Unity replaced old divisions. People worked together, not for profit but to see another sunrise. In the ruins, a new society was forged, illuminated by the best of the human spirit. The old world's boundaries faded, only shared struggle remained. Humanity found meaning in connection, resilience, and hope. The darkness was not the end, but a new beginning. As humanity endured, Earth itself transformed. Ice sheets pressed down continents, glaciers carved new valleys, rivers found new paths. The atmosphere changed. Carbon and sulfur from firestorms created wild, unpredictable weather. The Holocene's stability was gone, extremes ruled. As dust settled, the world revealed was alien and raw. Ferns spread across ash plains, signaling life's return. Plants cleansed the air, rebuilding the food chain. Abandoned cities were reclaimed by vines and insects. Resilient mammals emerged into a strange wilderness. Earth was not destroyed, but reborn, reminding us we belong to it. For those born in darkness, stories of the before time became myth. They learned of abundance and hubris, and the fragility of civilization. The memory of the Great Impact shaped new cultures. Cooperation and sustainability were now survival, not ideals. Settlements worked with nature, technology became stewardship. Science was reborn with humility. The Skyguard watched for threats. The trauma of the past brought wisdom and vigilance. Every decision was informed by the interconnectedness of life. The goal was not just survival, but resilience and harmony. The Great Impact was humanity's final exam, and the survivors were determined to pass. The future was built on lessons learned from loss. Decades later, the sky cleared, the sun returned, pale but persistent. Ice sheets retreated, rivers and lakes reawakened, and life exploded anew. Dormant seeds sprouted, forests of new trees spread, animals flourished in empty niches. Humanity emerged, blinking in sunlight, awed by a world reborn. Settlements were modest, integrated with nature, powered by sun, wind, and geothermal heat. The new world was wilder, quieter, and more beautiful. Clean air, clear rivers, and star-filled skies marked the planet's renewal. Humanity had lost much, but gained humility and purpose. We became caretakers, not conquerors. The long recovery proved the resilience of life and spirit. The Great Impact was Earth's harshest lesson and its most profound. We learned we are part of a vast cosmos subject to its laws and chance. The asteroid was made of the same stardust as us, a reminder of our shared origins. From the ashes, a new civilization arose, valuing life's fragility and interconnectedness. Technology aimed for harmony, not dominance. Exploration sought knowledge and security. Our perspective shifted from terrestrial to cosmic. To survive, we became citizens of the universe. The world now lives in balance, remembering trauma with wisdom. We look up with wonder and vigilance, knowing the universe is both beautiful and indifferent. Our survival depends on intelligence, cooperation, and perspective. Life and humanity have endured, scarred but wiser. We are the children of the stars, finally awake to our responsibility and wonder. Have you ever paused to consider the world around you, to truly wonder at the changing tapestry of our planet? Have you ever wondered why we have seasons, those distinct periods of warmth, cold, growth, and rest that shape our lives and landscapes? It's a question that has intrigued humanity for millennia. Or, gazing up at the night sky, have you ever pondered why the moon is always there, a constant companion in our celestial sphere? Why does it go through its phases, waxing and waning in a predictable dance? What is its purpose, its role in the grand scheme of the cosmos? These are cosmic questions. Questions that delve into the very fabric of the universe, rooted in the very origins of our planet, in the fiery crucible of its birth, and the subsequent eons of transformation. The answers aren't simple. They require us to unravel complex scientific principles and piece together clues from the distant past. They're written in Earth's ancient, tumultuous history, etched into the very rocks beneath our feet, whispering tales of unimaginable events. The rhythm of our lives, from holidays, those celebrations that mark the passage of time and the changing of the seasons, to harvests, the culmination of nature's bounty and the reward for our labor, is tied to a violent event billions of years ago, a cataclysmic encounter that forever altered the course of our planet's destiny. The gentle waves that lap against our shores, the predictable length of our day, the rising and setting of the sun, even the simple comfort of a summer afternoon, the warmth on our skin and the long hours of daylight, all are consequences of a cosmic partnership, a celestial dance between Earth and its constant companion, the Moon. Our planet wasn't always this stable or predictable. It was once a chaotic and volatile place, subject to forces beyond our comprehension. The world we know is the legacy of a cataclysm, a cosmic event of unimaginable scale and power. That knocked Earth sideways, tilting its axis and giving us the seasons, and simultaneously gifting us with the Moon, our celestial guardian. To understand our world, to truly grasp the significance of these events, we must travel back through the vast expanse of time, before life, before the emergence of the first organisms on our planet, before oceans, before the vast bodies of water that cover our planet and sustain life as we know it, to a time when Earth was a molten chaos, a seething ball of lava and rock, a world unrecognizable to us today. The story of our seasons and our moon, the story of the familiar rhythms of our year and the constant presence in our night sky, is the story of Earth's wild beginnings, a tale of cosmic collisions and planetary transformations. So, let's rewind the clock 4.5 billion years. Let's journey back to the very dawn of our planet and discover how a cosmic collision, a monumental clash of celestial bodies, shaped everything we know, everything we take for granted. This isn't just an astronomy lesson. It's not just about stars and planets and distant galaxies. It's our origin story, the epic saga of how our planet came to be and how we came to be on it. Picture early Earth, not blue and green but a glowing molten sphere. The Hadean Eon was a time of fire and fury with magma oceans and constant asteroid impacts. There was no solid ground, no breathable air, just a toxic haze and a world spinning through a 6-hour day. Imagine the sun rising and setting 4 times in what we now call a day. No moon graced the sky, nights were pitch black, lit only by magma's glow. There were no tides, no gentle rhythms, just chaos. In this violent state, Earth was primed for a dramatic encounter that would change everything. The stable, predictable world we know was still unimaginable. The stage was set for a collision that would give Earth its identity, its day, its seasons, and its moon. The greatest show in Earth's history was about to begin. In the infancy of our solar system, Earth was a vastly different place. A seething ball of molten rock, bombarded by asteroids, a landscape of fire and brimstone. How did this primordial chaos, this fiery crucible, eventually cool and coalesce into the vibrant, life-sustaining world we know today? What pivotal events shaped its destiny, transforming it from a hellish landscape to the blue planet teeming with life? The answer, according to the prevailing scientific theory, lies in a cataclysmic event. Enter the giant impact hypothesis. 4.5 billion years ago, in the chaotic early days of our solar system, when planets were still forming and celestial bodies collided with alarming frequency, a Mars-sized protoplanet, a celestial body of significant mass and potential named Theia, was inexorably drawn into a collision course with the young Earth. Their destinies were intertwined, heading towards a moment of unimaginable cosmic impact. Theia struck Earth not head-on, but at a glancing angle, a trajectory that would prove crucial to the events that followed. The impact unleashed an unimaginable amount of energy, a cosmic explosion that dwarfed any event we can comprehend today. The force of the collision was so immense that it vaporized Theia almost entirely, along with a significant chunk of Earth's mantle, the layer beneath the crust. This cataclysmic event ejected a massive plume of molten debris, a fiery spray of planetary material blasted far out into space. This ejected material, a swirling cloud of hot rock and vapor, eventually coalesced, forming a glowing ring of debris encircling the Earth. Then, the relentless force of gravity took over, beginning its work of shaping the cosmos. Slowly, inexorably, the debris began to clump together, drawn together by mutual gravitational attraction. These clumps collided and merged, snowballing into a single, ever-growing sphere of molten rock. This sphere, forged in the crucible of cosmic collision, was the nascent moon, the Earth's new companion. Born in fire, the moon was initially incredibly hot and much closer to Earth than it is today. From the surface of the early Earth, the moon would have appeared enormous, a breathtaking and awe-inspiring sight in the sky. This Great Whack, as it's sometimes called, wasn't just an act of destruction, a cosmic demolition derby. It was also an act of creation, a pivotal moment that shaped the future of our planet. From the violence and chaos of this collision, the moon emerged, a testament to the power of cosmic forces. The moon is not a foreign body but rather a sibling, forged from the very substance of both Earth and Theia, a cosmic blend of two worlds. With its birth, this new companion began a cosmic dance with Earth, a gravitational ballet that continues to this day. This dance, this gravitational interaction would profoundly shape our planet's destiny, influencing everything from its rotation to its climate. The collision therefore set the stage for everything that followed, laying the foundation for the world we inhabit today. It influenced the tilt of Earth's axis, giving us our seasons, and it is the primary driver of our ocean tides, the rhythmic ebb and flow that shapes our coastlines. Perhaps most importantly, it played a crucial role in the evolution of life on Earth, creating a more stable and habitable environment. The moon's birth, therefore, represents a pivotal turning point, a watershed moment. It marks a fundamental shift in Earth's story, a transition from a chaotic beginning to a more stable and predictable existence. From the initial chaos of the impact, a new order began to emerge, a system of interconnected celestial bodies. The cosmic partnership between Earth and Moon had begun, a partnership that continues to shape our world to this very day. The cataclysmic collision with Theia, a Mars-sized protoplanet, wasn't just a fleeting moment of destruction. It did far more than simply create the moon, our celestial companion. The consequences of this cosmic event rippled through the very fabric of our planet, shaping its destiny in profound and lasting ways. It tilted Earth's axis, a seemingly small change that would ultimately dictate the rhythm of life as we know it. This axial tilt is the reason why we experience the beautiful and dynamic cycle of seasons. Before this colossal impact, Earth spun upright, perfectly vertical in its orientation. This meant that sunlight would have struck the planet evenly across its surface, resulting in a world with no distinct seasons. Instead of the familiar cycle of spring, summer, autumn, and winter, there would have been just endless extremes, with some regions perpetually scorched by the sun and others locked in eternal ice. The force of the impact knocked Earth sideways, a violent shift that forever altered the planet's relationship with the sun, tilting its axis to approximately 23.5 degrees. This seemingly arbitrary number holds the key to understanding the seasons. This tilt is precisely why we have seasons, the driving force behind so much of the natural world's activity. As Earth gracefully orbits the sun, embarking on its annual journey, different regions receive sunlight more directly, experiencing varying intensities of solar radiation. This dance between the Earth's tilt and its orbit creates the beautiful and predictable cycle of seasons at different times of the year. When the northern hemisphere tilts toward the sun, basking in its warmth and light, it's summer, a time of growth, abundance, and long, sun-drenched days. Conversely, when it tilts away, retreating from the sun's embrace, it's winter. It's important to remember that the seasons aren't about Earth's distance from the sun, a common misconception. They're all about the tilt, the angle at which sunlight strikes different parts of the Earth throughout the year. This cycle became the heartbeat of life on Earth, a fundamental rhythm that shapes the behavior and survival strategies of countless species. Plants, animals, each attuned to the subtle cues of the changing seasons and entire ecosystems, intricately woven together by the threads of seasonal change, evolved in response to the changing seasons, adapting their life cycles to thrive in specific conditions. The tilt created diverse climates, from the lush rainforests to the arid deserts, each with its own unique set of challenges and opportunities, driving the evolution of life, fostering an incredible array of biodiversity, and shaping the course of natural selection. That ancient collision didn't just give us a moon, a silent guardian in the night sky, it gave our planet a pulse, a rhythmic beat that dictates the ebb and flow of life on Earth. The rhythm of the seasons is the legacy of a single, cosmic event, a testament to the interconnectedness of the universe. Our world's diversity and stability began with that ancient punch, a reminder that even the most violent events can pave the way for beauty and life. The moon's influence didn't end with its creation. Its gravity pulls on Earth, creating ocean tides, 2 high tides and 2 low tides each day. Tides shape unique ecosystems and have slowed Earth's rotation, stretching our day from 6 hours to 24. Most importantly, the moon stabilizes Earth's tilt. Without it, our axis would wobble chaotically, making seasons unpredictable and life unstable. The moon acts as Earth's anchor, keeping our climate steady over eons. Without this stability, complex life and civilization might never have emerged. The moon is our planet's silent guardian. How do we know this story is true? The evidence is in the rocks. Moon rocks brought back by Apollo missions are nearly identical to Earth's mantle, but lack a core's heavy elements. If the moon formed elsewhere, its chemistry would be different. Its dryness and lack of volatile elements point to a fiery, high-energy birth. Computer simulations of a Mars-sized impact match the moon's mass, orbit, and composition. The physics and chemistry align. This is no longer just a theory. The moon's very existence is proof of our violent beginnings. The story is written in stone and dust. The ancient collision shaped not just Earth but human history. The cycle of seasons became the clockwork of civilization, guiding agriculture, migration, and survival. Mastering the seasons led to farming, villages, and cities. The moon's tides fed coastal communities and guided sailors. Its phases gave us the month, and lunar calendars shaped cultures worldwide. Our myths, festivals, and beliefs are woven into the rhythms of sun and moon. The structure of society itself is built on the legacy of that cosmic event. Our world's order is a gift from the chaos of the past. Even today, the moon and Earth's tilt shape our lives. Tides drive shipping, power tidal energy, and sustain coastal ecosystems. The moon is a time capsule, preserving the solar system's history. Eclipses, made possible by a cosmic coincidence, have advanced science and inspired wonder. Earth's tilt drives climate and weather, crucial for everything from food supplies to holidays. The moon and tilt are not relics, they're active forces in our daily lives. The ancient impact still echoes in every season, every tide, every day. Our cosmic partnership continues. To see how special our moon is, look at Mars. Mars's tiny moons can't stabilize its tilt, so the planet wobbles wildly over time. This chaos brings extreme climate swings, making stable life nearly impossible. Mars's lack of a big moon may be why it's barren while Earth thrives. The moon's stabilizing presence is a rare cosmic gift. Our moon's formation was a cosmic accident, a lucky break. Without it, Earth might have no seasons, or seasons too wild for civilization. Every tide, every season, every day is a reminder of that ancient collision. The moon is the other half of Earth's story. Next time you see the moon or feel the change of seasons, remember Theia's sacrifice. Our world's beauty and stability are the legacy of a single spectacular event.